Hello, my name is Otavio Fonseca Ivo and I'm a Bru21 PhD candidate in engineering cybernetics. Before this position, I did my master's degree in chemical engineering at the Federal University of Rio de Janeiro. I'm here today to talk about my working topic, which is within production optimization strategies for offshore production systems with water processing constraints. This project is currently being sponsored by Okea. So when we think about produced water management, we know that produced water is by far the largest byproduct stream into the oil and gas industry. And historically, it has been treated as a waste stream. As time has passed on, produced water management has changed a little bit, with having some focus into waste to value conversion, where we basically want to minimize the produced water that's being produced. We want to also reuse this produced water as an asset, and we also want to correctly dispose of this produced water. So we take a look into the produced water reinjection, and which is considered the best environmental practice for produced water management. And why is that? Because produced water can be used as a resource for enhanced oil recovery by keeping the pressure into the reservoirs, or you can also use it for disposal by reinjecting the produced water into non-producing formations or also discharging towards the ocean. Okay, but however, to discharge to the ocean, you need to cope with certain restrictions towards the discharge policy, such as, for example, the oil in water content needs to be below a certain threshold. So I've been working within the Draugen field from Okea, and it's considered a mature field, and as you can see here, as time has passed, the amount of produced water that this field has been producing has increased a lot. Therefore, this study case is important one. So a produced water injection facility is generally comprised of the gasser, booster pumps, injection pumps, valves, reinjection wells, and also a discharge towards the ocean. Mainly, we need to make some decisions when operating this process. How much water should we discharge? How much water should we reinject? To which well should we reinject? Should the pumps be on or off? Which rotation should be each pump? And do we need to use recycle to protect these pumps while they operate? So we look into a decision-making framework, which comprises of several hierarchy, and there is kind of information being passed from one hierarchy to the other. And then we look into the current produced water reinjection control philosophy that is currently being used into the system. So basically, the reservoir management is done by having some reinjection targets, which is obtained through reservoir simulation and reinjection set tests. And this is given as a set point towards the control system, which is going to control the reinjection flow rate and the gasser level. So this structure does not consider pump energy consumption, waste to water conversion, and oil in water monthly average restrictions. So we are proposing to keep how the reservoir management is currently being done, but we want to overhaul the production optimization part and a little bit of the control and that automation. First, we want to add a monthly monitoring of the oil in water content into the produced water, such that it stays below the monthly requirement restrictions. And well, this is passed down to the other control aspects, to the other optimization layers, where these restrictions are going to kind of restrict this problem, such that we can then improve over waste to value conversion. We can select which pump should be operating. We can then meet the daily reinjection targets, and also this information is passed towards the hourly operation layer. where we want to set the regulatory system, and we also can operate efficiently, energetically. Thank you all for your attention.